Welcome back to my channel. I am Kaushik, Yosono Kaushik. So it's been a while, I guess. Last time I posted it was May, and you are probably seeing this video in July. This video is about a classical organic reaction called the iodoform reaction. This reaction may be used to identify the compounds having ketomethyl group, or the compounds which may easily be converted to compounds which are having the ketomethyl groups. These are the timestamps, the useful timestamps. So this reaction may be useful to identify the compounds like acetone. One can identify if a product really has acetone or not. In Indian market, this type of nail polish remover, I won't show the brand, are commonly sold, and the shopkeepers told us that it contains acetone, but they really don't. I have tested them with the Iodoform test, and they always show negative result. So they are fake products, and they scam people with missing information. Prega el Signore, the Iodoform test. I will flip the video. Andiamo, let's go. So let me discuss the mechanism of the iodoform reaction and the haloform reaction in general. So iodoform reaction is a type of haloform reaction. Okay, it is a type of haloform reaction, and other haloforms are chloroform and bromoform. You know chloroform, right? I think you know. So what are the uses of the haloform reaction or iodoform reaction? It is applicable for the identification of methyl ketones or alcohols that may be oxidized to ketone or aldehyde having ketomethyl group. Okay, that are having the ketomethyl group. Also useful for acetaldehyde, because acetaldehyde also has a ketomethyl group, that is CH3CO. So let us see some examples of such compounds. So this is our acetone, and acetone has ketomethyl group here. This part is called ketomethyl group. Conversely, this part may also be called ketomethyl group, but only one part will undergo the reaction, and the other part will remain inert. So this is the ketomethyl group. So why does ketomethyl group undergo such reaction? Because of -I and -R effect of the carbonyl. Because the carbonyl has -R and -I effects, so it withdraws electron from this alpha carbon, and consequently from these alpha hydrogens. So they are pretty much electron deficient, and thus they are acidic in nature, and hence this alpha hydrogen are deprotonated easily by a base like OH minus or something like that, leading to haloform reaction. Okay, another example is acetophenone. Obviously only this part, there is an error, only this part participates in this reaction, and the benzene ring is inert obviously. And 2-butanone, for 2-butanone only this part will participate in the reaction, the haloform reaction. And this is the example of pent 3-one, and pent 3-one won't react at all, because although the hydrogen on alpha carbon is undergoing the effects, the -R and -I effects of the carbonyl, but these effects are relatively neutralized by the +I effect of the beta methyl, this beta methyl part, CH3 part. Okay, so these type of compounds do not react in haloform reactions. What is the general reaction? So it is generally represented by this thing. So this is a carbonyl compound having alpha methyl group. This is the alpha methyl part, and this is a carbonyl compound, CARBONYL, carbonyl. And under this condition with a halogen, X2 is a halogen, and X2 must be chlorine, bromine or iodine. Fluorine does not participate in halofrom reaction because fluorine bond energy is too much to be broken in such a reaction. And H and the R group, this R group may be hydrogen, may be alkyl, or may be aryl. Aryl group means like benzene or an aromatic system, okay? And after this reaction we will get carboxylate. This part becomes carboxylate, an oxygen is attached, and we will get from this part we will get this haloform. We must discuss about some properties of iodoform. So iodoform is pale yellow in color. It is shown on screen, okay? Crystalline substance. It is crystalline and virtually insoluble in water. The solubility in water is pretty low, but it is somewhat soluble in organic substances like acetone. The odor is clinical or hospital-like. It is typically used as a disinfectant, and thus you may be familiarized with its smell. It smells like hospital. Let us discuss the reaction mechanism now, the full-on mechanism. Step 1. But step 1 is not important for the compounds which already have the ketomethyl group like acetone or 2-butanone, etc., or acetophenone also. So the step 1 is the generation of hypoiodide, and this is useful for iodoform reaction of isopropyl alcohol and ethanol. Why, we will discuss it a little later, but let me say this part. So iodine reacts with 2 OH minus, that is in basic medium, say from NaOH. I have used NaOH in this reaction, okay? In the practical part we will get iodide I minus, and hypoiodide. It is similar to hypochlorite. Sodium hypochlorite bleach, right? It is similar to that. It is basically the iodine version of the bleach, and you will get water also. And this part is a powerful oxidizer. This is a powerful oxidizer, and this part will oxidize the alcohols, the alcohols which may be converted to compounds having the ketomethyl group. How, we will discuss it a little later. So let me discuss the step 2. The step 2 is the reaction and formation of triiodinated carbonyl. This is our ketomethyl group and the corresponding carbonyl compound. So in presence of basic medium, it will undergo this reaction. So these hydrogens are acidic, as I have discussed earlier, and OH minus snatches this hydrogen and it is pushed back, and negative charge comes on this carbonyl oxygen. The carbonyl carbon oxygen double bond breaks to a single bond. So we will get this enolate entity, and the enolate entity will undergo resonance to form a keto entity, and this is stabilized by the keto-enol tautomerization. The oxygen will push back to this carbon, and this carbon double bond will break, and this will attack the iodine I2, and iodine is polarized, okay? There is partial positive and there is partial negative on this. This is delta plus and delta minus, and this bond will break to generate I minus, and the I minus is removed. And why is this favored? Why is the carbon oxygen double bond formation and the formation of this and the progression of this step is favored? This is because the bond energy of carbon oxygen double bond is much more than carbon oxygen single bond. Thus we will get the monohalogenated product, monohalogenated or monoiodinated, because there is only one iodine, and this reaction will take place twice. and we will get the trihalogenated product or triiodinated product. How this triiodinated species or carbonyl is converted to haloform, let's see. So this carbonyl group, as we know, is an electrophilic entity. This part is partially positively charged and this part is partially negatively charged, and OH minus is a nucleophile, so this will attack this electrophilic entity, this electrophilic site, and this bond will be broken. So we will get this entity. This is an addition reaction, obviously. And after that, what will happen? As I have said, the carbon oxygen double bond is much more stronger than the carbon oxygen single bond, so this bond will break and carbon carbon bond will be broken, because carbon oxygen bond is stronger than carbon carbon bond. So this bond is broken and we will get carboxylic acid from this part, and Ci3 or CX3 minus, the conjugate base of haloform basically, or iodoform, from this part. Now this entity is somewhat stable because the carbon here is sp3 hybridized, and sp3 to 5d, iodine has vacant 5d orbitals, and sp3 to 5d donation occurs to some extent, though it is very weak compared to sp3 to 3d donation like in chlorine. So CCl3 minus is much more stable than Ci3 minus. This is another question that may come in some exams or something like that. This will attack this part and carboxylic acid will be converted to carboxylate, and carboxylate is stabilized by resonance. So it undergoes resonance and hence it is stabilized, and we will get haloform or iodoform in this case, and in some other reaction we may get chloroform or something like that. Now the question is, why does OX minus or OI minus oxidize isopropyl alcohol or ethyl alcohol? Or the question is, why do isopropanol or ethanol respond to the iodoform test? Do you remember step 1? So in step 1 we did get this entity. This is hypoiodite or hypohalite. Is very oxidizing. It is a strong oxidizer. So what will it do? So we already had OH minus in the medium, and this hydrogen is somewhat acidic. It is not that much acidic. This hydrogen will be taken out and the whole part leaves as H2O. Now this ion is not that much stable, but it reacts immediately with Y minus to form this entity ketomethyl with ketomethyl group. So this reaction is driven forward only because of that. Otherwise the chances of formation of this type of ion is pretty low in a medium with alkali and alcohol. Now what does happen? This this oxygen pushes to the carbon, and as we know, carbon oxygen double bond is much more stable than carbon oxygen single bond. Why? Because the bond energy of carbon oxygen single bond is lower than the bond energy of carbon oxygen double bond. So this hydrogen will be sent to this oxygen, and this oxygen iodine bond will be broken, which is very much unstable to begin with. Now we will get this entity with ketomethyl group. So is this familiar to you? And before going to that, we will get OH minus back. OH minus is acting as a catalyst here. So are you familiar with this part? It is basically the same thing, and hence this reaction takes place like I have shown here, blah 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 blah. Let's move to the reaction part quickly. Let me welcome you to the experiment part of this section, and I will be using acetone to perform iodoform reaction, but you can use anything else as I've shown before. So we will basically need iodine solution, and this iodine solution can't be prepared on its own, so we add iodine crystals to distilled water, and then we add some amount of Ki. I will provide the measurements, and this is done because the solubility of elemental iodine in distilled water is very low. And we'll also need the sample. I am using acetone, you can use anything else. And this large thing, this is a dilute NaOH solution. So let me proceed. So at first we will have to add the NaOH solution, the dilute NaOH solution, to the I2Ki solution in a dropwise manner, and it will cause to form NaOI, and this will be our oxidizer if needed. In this medium the reaction proceeds, and I have shown you the reaction mechanism before, so I guess you can relate it. Okay, always use a clean dropper for the dropwise addition of NaOH. The mixture is shaken afterwards. Using another clean dropper, dropwise addition of acetone was performed. The mixture is shaken gently. The formation of pale yellow crystals and the evolution of hospital-like smell may be evident immediately. However, if it's not the case, you may need to heat the mixture gently on a low flame for a short period of time. That is the gentle heating, and you may see the formation of pale yellow crystals in my case. So this is the final product, the pale yellow crystals of iodoform. So if you like this video, you can leave a like if you want, and you can check my social media in the description. I guess I will see you next month or in 2 months. For now, you can suggest me any idea via Instagram or via Facebook or something like that. I think you should use Instagram for that. I am not much active on Facebook, and you can also use the comment section to suggest me any kind of ideas. So thanks for watching. Ciao. Bye. Ciao.